All right, so this is 11.2 part 2, the second page of notes. And this is about kind of working with composite shapes and maybe pieces are missing. So here, like this first one, well, let's remind ourselves that the area of a circle is pi r squared. So here I want to find the area of the shaded region. So essentially I want to find the area of this big circle and subtract the little circle. Now, so the area of the big circle would be pi r squared. The radius of the big circle is 17. And that gives me 907.92. The area of the little circle, pi r squared, is pi 3 squared. But rather than actually using these decimals, I'm going to put it in my calculator all at once at the end. So 17 squared is 289. So 289 pi, and the little circle is going to be 9 pi. So the area of the shaded region here is going to be 289 pi minus 9 pi, and you can put that right into your calculator just like that. 289 pi minus 9 pi. So you don't have to type in any decimals, you just get them at the end. So 879.65. And it's going to be in square units, and what are the units? They are millimeters. Here, the area of the shaded region would be the square minus the 4 circles. So, the area of the square is 10 times 10, because the square is just the sides multiplied by each other, base times height. 1 circle, pi r squared, what is the radius? Well, it shows that they're all the same, which means these 4 pieces would be the same. So it's actually going to be a fourth of 10. Each of these radii are going to be 2.5. So you have 1, 2, 3, 4. So the area of the circles are going to be pi times 2.5 squared or 6.25 pi. Remember, I want 4 of those. So I have 100 minus 4 times 6.25 pi. You can do the pi early on and keep writing out decimals, but you want to make sure you're writing enough decimals so at the end you're not far off from all the rounding. So 100 minus 4 times 6.25 pi, and that gives me 21.46. And this time it's centimeters, so it's going to be centimeters squared. This one, it kind of looks like a dartboard. So with this, you want to think about as a whole. Essentially, I want to take this big circle. I'm going to call it circle 1, the biggest one. Subtract the second biggest. Add the next biggest. And then subtract the next. So if you were to put down the biggest one. If you were to cut out the second biggest one, you'd be missing too much. So then we add in the next piece and subtract. So it's showing that each piece of this is 5, and they're all the same. So essentially I want to do the area of 1 minus 2 plus the area of 3 minus the area of 4. I know that there's a lot going on there, and I can definitely stop by office hours and we can go over it more. So the area of 1 pi r squared, what is the radius? If each of these is 5, the biggest one is 5, 10, 15, 20, 25. So the area of 1 is 625 pi. The area of 2, pi r squared, 5, 10, 15, 20. That's 400 pi. The area of 3 would be pi times 15 squared, or 225 pi. And the area of the fourth one, you see the fourth one is actually kind of this whole thing. We're not doing anything with that little one. So pi 10 squared, or 100 pi. So to get the shaded, I'm going to do 625 pi minus 400 pi plus 225 pi minus 100 pi. I put that all in my calculator. So 625 pi minus 400 pi plus 225 pi minus 100 pi. It's going to give you 1,099.56. So just as an example, if this is going to be meters squared, if you do it so that you're writing out the decimals each time and not the pi's, you're going to get, your decimal is going to be a little bit off the end. It's fine, but the pi is just going to give you a more specific answer. All right, so here it's a sector. So remember, we have the area of a sector was this area of the sector over the area of the circle equals the angle over 360. So essentially I want the area of the big sector minus the little sector. So I want to find this whole thing, this big sector, and I want to subtract this little one here. So to find the big sector, it's over the area of the circle. So pi, what is the radius of this big one? Well, it'd be 4 plus 6 equals the measure of the angle over 360. I'm going to call it b. So 360b, because I'm cross multiplying, equals 100 times 45, 4,500 pi, divide by 360, 4,500 pi divided by 360 is 39.27. So that's the biggest one. Now the little one, it's over the smaller circle, so over pi r squared, 4 squared. It's still 45 degrees, so that doesn't change. So I'm going to get 360 L is, what's 16 times 45? 720 pi. Divided by 360, you get 720 pi. Divided by 360, you get 6.28. So that's the little one. So the shaded is going to be 39.27 minus 6.28, which is 32.99. What are my units? Inches squared. So they use area a lot for different real-world applications. One of them is population density. So population density is all about how many people are in a certain square area. We usually, in America, we use square miles. So you can have an idea in Boston has a much higher population density than maybe like a rural town in Wyoming. So for population density, we have an equation. So the equation for population density is the total number of people over the area of land. So about 430,000 people live in a 5-mile radius of a city's town hall. So we have that center. This is town hall. And a 5-mile radius, that kind of means it's all out here. So find the population of people per square mile. So we know the number of people. It's 430,000. We need to find the area of land. The area, it's a circle with a radius of 5. So it's pi 5 squared. That gives us 5,475. So the answer is 5,475 people per square mile. That is how that is done. Here, a region with a 3-mile radius has a population density of about 6,195 people per square mile. What's the number of people in the region? So in this case, it's the population density equals the number of people over the area. So here we're looking for the number of people instead. So they gave us the population density, 6,195. And they gave us the radius, so the area would be pi times r squared. So what I would want to do, because this is what I want, I'm going to multiply both sides by 9 pi. Because the number of people is what I want. So 9 pi times 6195 equals something with a decimal. Now, logically, it's asking how many people live. So people are whole. So when you're talking about something like this, we round up. We round up to whole people. There are no half people. So we get 175,160 people. All right, now you can get started on your 11.2 homework.